you have seen stick to PL whatever is happening in stick to PL only in stick to PL whatever is happening. You can see that in stick to PL all exclusive lock. I already taught you this portion before. All exclusive lock should should not be unlocked. Yeah, should be hold. All exclusive lock should be hold until commit or rollback. That means at time of commit or rollback, all the exclusive lock which was there, it should be holded. That means we cannot unlock. If I have taken exclusive lock for this, I cannot unlock it over here. That means during after or just before the commit or rollback only exclusive lock can be unlocked. But in case of regress to peer, in this case, which lock was uh, hold till the end or till the commit or rollback? Exclusive lock only, not shared lock. But in case of regress to PL, shared and exclusive lock should be hold until commit or rollback. That means in this case, shared as well as exclusive lock should be hold until commit. So now you can see in this conservative 2PL. Conservative 2PL is saying that it means previous stick 2PL and regress 2PL were not able to avoid that law. But by using conservative 2PL, you can avoid the that law. In this, what is there? All the logs that required to complete the transaction, all the logs that required to complete the transaction should be holded before starting execution of the transaction. That means whatever the lock is needed for complete transaction, all the locks are taken before, and that has to be holded till the completion of the transaction. In this case, you can see this. Suppose it has to read A, read B. So for read A, read B, it has holded shared lock in initial time itself. Before itself, it will hold all the lock. After that, it will start executing its transaction, execution of the transaction. So here it needs write for C, so it has taken exclusive lock for C. Here it has to write on data E, so it has taken exclusive lock on data item. That means all the locks should be taken before itself, before starting the execution of the transaction, whichever locks are needed. So in this case, there is no possibility of death. That means one transaction will complete it one for those data items, then only that lock will be given to other transaction. Suppose it is not free from start. Now you can see that what is happening. Inefficient usage of resource. That means uh, other transaction cannot use. Suppose it is working. Suppose the transaction is working on data item A, and other transaction are want to work on data item, but it has holded log for B as well as for B. So it cannot take other transactions cannot take exclusive log during that. Because in initial itself, whatever log is required, all the transaction is taking log for all the data before initial stage. Then only transaction is starting, right? So if other transaction want to work on these data item itself or any one of these data items, so it next transaction cannot have the log. So resource utilization is minimum in case of prediction of required resource before execution. It is very difficult to predict which log I have to take before starting the transaction because it is not known whether it will guide the whatever it will perform in advance. It is very difficult to identify. May not be from irrecoverable. It is also not free from recoverable. Now I will talk about time stamp. These are the examples I will provide you so you can know in the notes. Now I'm talking about time stamp or the time is what is time stamp? Unique value assigned to every transaction in ascending order. That's time. So identify in first case we have to identify the transaction, set priority between the transactions. Time stamp with less time stamp value can given higher priority. That means higher priority is given to that. That means suppose transaction T is at 10 hours, means 10 is the time stamp for transaction T and 30 time stamp for transaction T and 20 time stamp for transaction T3. Now you have to find out. So I can say that equal serial schedule is based on order of time stamp value. That means how we will get equal serial schedule equivalent to this. What is the equal serial schedule for this? It is based on the time stamp value. That means time stamp value for this is T1 is 10. It is suppose it is given to right now it is given to, or you can calculate the time this transaction is started, whatever it is. So suppose now it is given to you that transaction T1 is started time T, transaction T2 started time 30, and transaction T3 started time 20. So what are possible and user possible? That means from less time stamp to more time. That means it, it's a time stamp is 10, so it can go from lower time stamp to that user can proceed from lower time stamp to higher time stamp. That means from T1 to T2 I can go, from T1 to T3 I can go. So T1 to T3 and T1 to T2. That means from T1 to T2 as well as T1 to T3 I can go because T1 is having less time stamp and from where there is less time stamp we can go to and user can proceed towards the more time. So you can see over here T1 time stamp is 10, T2 is 30. So we can go from T1 to T2 and user can go from T1 time stamp to T2 in the conflict. Similar with T1 is time stamp 10 and T3 time stamp is 20. So from T1 to T3. Similar with from T3 to T2. From T3 time stamp is 20, so we can start from T3 and the user can proceed to T2. That means it is 30. But you can see that 30 is more than 10. We cannot say that T2 can proceed to T1. T1 can proceed to T2, but T2 cannot proceed to T2. So allowed operation are like T1 from T3, that means less time it took to more time. And T3 to T2, that means 20 to 30. And similar case, you can see here T1 to T2. These are only valid operations which can be performed. This only proceeding allowed, no other precedence allowed. In this case, you can see that suppose there is transaction T1 time stamp 10, T2 transaction time stamp is 20. Suppose it is performing the right operation. Now it is going from here to here. After this after this time read operation is performed by lower time. That means from T2 to from T1 to T2 I can go. If suppose here is read and here was write. Suppose if it was read over here and write is over here, then we can proceed read and write because from T1 read started and next operation was write from T2. So from lower time step to higher time. But now here if you can see the write is performed first, after that read is performed. So these are conflict operations. But now you can see that if it is conflict operation and we are seeing that writing operation Now you can see that I said that from lower to higher timestamp we can do. That means we can do from T1 to T2. But here what is happening? After write a read a perform, that means from write it we are going towards the read it. And this timestamp is less. So we cannot go from T2 to T1. This is not valid. So in this case, T1 has to be wrong. So what is the read timestamp? You can understand what is the read timestamp. Read time is the highest transaction timestamp value that is performed read a operation successfully. That means suppose these are the transaction timestamp is given over here 10, 20 and 30. Now you can see that suppose which operation are allowed T1 to T2, T1 to T3 and T2 to T3. These are three operations which are allowed here. Now you can see from T1 to T3 we can go. That means from T1 to T3. First one is T1, next one is T3. So this read one timestamp is 10, and when it goes from read to here, that means after this operation perform, so from 10 to 30 we can go. So you can see this is allowed operation. This operation is allowed from lower timestamp value we are going towards the higher timestamp. So it is 10 from 0 timestamp becomes 10 for read operation, and it is allowed process from T1 to T3 can be so timestamp value becomes T3 30. Now higher timestamp. Now we can see that from this read A to read A, whether I can perform this operation, it is from higher timestamp 30 to lower timestamp 20. So we cannot perform from T3 to T2. We cannot do that. So you can see here read A, read A. This operation is not allowed here to. So you can see this in this case, what is the higher timestamp value? Higher timestamp value is 30. So read A because this operation is not. So in this way we calculate the timestamp. In the similar fashion, what is right timestamp a higher value? You can see T1 timestamp is 10, T2 timestamp is 20, and T3 timestamp is 30. You can see here from T1 to T2 we can move from T1 to T3, but we cannot move from T3 to T2 or T3 to T3 to T2. That means we cannot move from T3 to T2. Here you can see that timestamp is given for all the transactions. Now from writing operation, I can perform this writing next operation of this. Whether I can perform this operation or not, yes, I can perform this operation. So now writing timestamp value becomes 30. And now next operation is perform this one, so I will check it. From T3 I can go to T2, but from higher timestamp value I cannot go to lower timestamp. So in this all this case, what is the highest timestamp value for writing operation? Right timestamp value is 30. This operation. So, so now you can see that. Now you can see that. Suppose time. Now I will take another.